Dear champions, this is Leetcode contest, weekly contest number 231, starts in 40 seconds. Let's do it! Let's do our best, what we can do. Let's see. Let's go. 1 hour 30 minutes. So it's technically 130 minutes is like 90 minutes, right? So 90 minutes per 4 problems. Usually it's like 22 minutes only is given in Leetcode. 22.5 minutes. Interesting. Then let's make 20 minutes timer. Let's go. Number 1. So it's like 3, 4, 6, 7. Okay. Number 1. Check if binary string has at most one segment of ones. Given a binary string S without letting zeros. Given binary string 1 0. Okay. Binary string. And return true. If S contains at most one contiguous segment of ones. At most one contiguous segment of ones. True if one segment of ones. Otherwise return false. Interesting. So input S1001 false. The ones do not form a contiguous segment. S110 true. I think it is kind of interesting problem. So how are we gonna solve it without leading zeros? So the first should be definitely 1, right? So let's start like from let's see any onto constraints. S is between 1 and 100. S length between 1 and 100. S0 is 1, right? So the first number is anyway 1, right? There is no way. So if the length of S is 1, then we return true, right? So S0 is always 1, right? So it's definitely we have for sure that if length of S is equal to 1, right, then we definitely have S0 as 1 and we return true. This is the first thing. Next, here Si is either 0 or 1. So what we really need to do is we need to make something like this. We should go through the list, through this string, and check if it is 0 or 1. So the first one is 1, right? So the next one, if there are 2 cases, right? So if we actually just should go through the all numbers, other numbers, so it means that the first one should be so we should go and like if there is 0, we should go through this list, right, of other numbers. If there is 0, if there is 0, we make that now variable is 0, right? Now variable, let's say now variable true, and we go for let's say awk variable true, and we go through the list. If 0, then we change to false. So 0 was let's say 1 1 1 1 1 and 0. Okay, so if 0, then we change now awk to false. And now if we will find any 1 after 0, any 1, then we return false. And that's it. Yes, if there is, and also in the end, if we do not have any 0, we return true, right? We return true if all is 1. Yes, let's see the test case. So for the test case, it will be if there is 0 0 and after it 1. Yes, that's it. So let's say now variable is awk variable is true for now. Everything is okay. So we go for I in S starting from 1, right? And what we want to do is we want to check if integer I, we want to check if this is equal to 0, then we make awk to false. We change to awk to false. Okay, so after it, when it is false, or like in this case, when it is false, then if we it always will every time it will make false 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 false. And if there will be if awk false and int I is equal to 1, right, then in this case we return false, else we return true. We return true if there is no if we return true if so if there is if there is everything 0, then no problems, but else we will return false. Let's use test case. So here finished false, expect to enter not set, but we know that it should be false. And let's say 110. Let's check it here. Let's check it. True. This is true. Let's say if there is like this, then we have false, right? What if there is like 0 0, then true. Let's see if there will be mistake. Oh no, yes, perfect, done. So the first problem is solved. Now let's go to the second problem. Second problem, let's see, a little bit difficult, but we can do it, right? Minimum elements to add to form a given sum. Wow, seems not difficult. You are given, but yeah, let's do our best. You are given an integer array nums. Integer array nums. Array nums, and two integers, limit and goal. Okay, two integers, limit and goal. This is like mathematical problem, you know, like for entrance to the university, very kinda easy. The array nums has an interesting property that absolute number of nums I, nums I is less than or equal to limit. So this is initial property of nums. Okay, the array nums has an interesting property that absolute value of nums I is less than or equal to the limit. Returns the minimum number of elements you need to add. Minimum number of elements you need to add to make the sum of the array equal to goal. What does it mean? Return the minimum number of elements you need to add to make the sum of the array equal to goal. Okay. Minimum number of elements. So that equals to goal. Equals. The array must maintain its property that absolute nums I is less than or equal to limit. So we should add like limit and the rest. Note that absolute x equals x if absolute x equals x what? if x, yes, absolute x equal to x if x more than or z equal to 0 and minus x otherwise. Yes. So minimum number of elements. What is the thing about absolute value? I didn't really get it. So nums 1 1 1 sum of the array. Sum of the array equal to goal. Oh my gosh. Sum of the array. Interesting. Let's see. Input nums 1 minus 1 1, limit 3, goal minus 4. So in this case, goal minus 4. What is the current? Initial is 1. So what we need to do is you can add minus 2 and minus 3. Then sum of the array will be minus, I think it's better to add minus 3. Minus 3 and minus 4 and minus 2. Yes. Now I understand. So depending on which side we need to go, do we need to increase or decrease the number? Depending on this stuff, we will add plus limit or minus limit until like mode is more than limit. Yes, right? So yes, nums 1 minus 10 9 1, limit 100, goal 0. So 1 is enough. Number of elements, minimum number of elements. Wow, so interesting. Let's see. Nums length. Oh my gosh. Length of the nums is 10 to the power of 5. Oh my gosh. 1 limit from 1. Oh my gosh. Minus limit, nums I, limit. Yes, nums I should be minus limit, and goal. Oh my gosh. Oh my god. Well, I think this is pure mathematics. It's not really programming. We should come up with some formula. Interesting. Let's do our best. So for this kind of problem, what do we need to do? I think what we can do is set 20 minutes again. So let's do it. How do we solve this problem without programming mathematically? So number one, I think we should check if the sum is equal to nums, right? If sum of the nums is already equal to goal, then the number of elements to add is 0, right? Return 0. Easy. Now we have limit and goal, right? So in this case, we should check. I think we should check if limit is bigger or lower. If the sum right now is bigger or lower than the goal, right? So if sum of the nums, yes, I think this is the defining point, more than or more, it cannot be equal, right? Equal already done. So if it is more than goal, if sum of more than goal, then we need to decrease, right? Let's say we need to decrease, and if sum of the nums is less than the goal, in this case what we are gonna do is we need to increase, right? So if the sum of the num is less than the goal, we need to increase. Yes. So let's say we need to decrease, and I think the only thing we need to do here is actually just calculate the difference, right? This is just, so let's say for example the first case, right? So when we need to decrease number, decrease is here, right? The first case, so it was like 1 minus 1, and this is very easy. Okay, yeah, this is like a difficult explanation, but very easy. So we have goal minus 4. initial sum is 1, right? We need to go to -4. What we need to do is we need to find things. Number one, we need to find how many times do we have the so -4, right? -1. The difference, yeah. So we should go -5, right? Generally, in this case, 1 minus 5 is equal to, yeah. And so we need to count this number. Let's say it is like the difference, right? Yeah, difference. Let's say difference equals to goal minus some nums, right? So this is the difference, and we need to do what we need to do is to divide this by our limit, right? I think it doesn't really matter plus or minus, right? In this case, yes. Let's say we divide by the limit, and it will be how to divide. So we know that in Python, if we make division 2 times, it is kind of cheating, but let's say as I know, it shows is it Python? Divide with integral result, discard remainder. Yes, so I know it was not cheating, I did know it. So what we do is we make the difference. Let's say it's like let's say nums, I think lms is equal to difference we divide by sum of the nums, right? Well, we divide it by the limit. Yes, we divide it by the limit, and in this case it doesn't matter how do we divide, right? We just divide by the limit, and it is equal to 1, right? Yes, it is equal to, we divide by the limit, and this is the lms, number of elements, right? Actually, and we check if, and this one, and also what we need to do is we need to check, for example, if it was -3, then when we divide it, let's say sorry, -6, so when we divide it by 3, it will go integer number -2, right? And what we need to do is we need to check the remainder, right? So for checking the remainder, okay, what we need to do is, what does it matter, plus or -3? Let me think about it. If we do it in this way, remainder, so -5, we divide it by, does it matter minus or I think it doesn't matter, like let's say just AB, right? Yes. What we need to do right now is we need to think about it in this way. So right now we are decreasing, right? Anyway, we right now are decreasing. Initial goal was something, and we need to decrease. So anyway, we will minus limit, right? Yes. So what we need to do is check the remainder is equal to initial goal, initial sum, right? Initial sum, and minus this difference is this lms multiplied by lms, but multiplied by, we anyway in this case we right now need to decrease, right? Yes. So in this case, 1 minute, remainder is some nums. So it will be -5. lms is 1, and also multiplied by I think we just need to check if there is mode, if there is remainder or not. If there is remainder divided by this number, right? Yeah. I think this is kind of mode in Python. Yes, I think I will learn. I need to learn the things. The percentage operator. Yes, right. So percentage. Let's see. Yes, the reminder in Python. Yes. So we just need to make percentage, and it shows us the reminder. And we check if the reminder is 0, if sum of the nums. No, if what? We need to check if the reminder is sum of the nums. No, we need to do is goal is -4. This one is 1. So in this case we need to decrease. We know that we need to decrease, and if this is the decreasing, then what we need to do is we need to check. Oh my gosh, 1 minute. Okay. Let me concentrate my attention, please. Difference. Yes, right now I got it. So if difference percentage lms percentage lms multiplied limit. It is very easy problem. Come on, you can do it. Let's do it. Okay, I think it is bad idea to use the example. We need to make like ABC, right? Yes, so we have sum of the nums. We have some limit, and we have goal. Yes. So in this case, what we are checking, we checking number 2 cases, and when the goal is less than the initial sum of the nums, and we have limit, and we have to make the from minus limit. Every number we add is minus limit or plus limit. So the thing is that when the sum is bigger than the goal, what we need to do is we should add the elements minus, right? So the second case, when the sum of the nums is less than the goal and the goal is bigger, then we need to add plus limit, right? That's it. Yes. So here, let's say that in our case, what we should check is the reminder. So lms already we have lms, and also we should check the reminder. If there is anything else we should add. If yes, then we add the additional number. So for this thing, we know lms is a kinda lms, we said that it is the difference divided by the limit, right? So in this case, difference divided by the limit, difference is goal minus nums sum. Okay, so we goal minus sums minus sum is the difference, and lms is the difference divided by limit. Yes, we should feel this difference, right? This difference when the goal is less, this difference is kinda, should be negative in this case. Goal is less. So when we make goal, I think we should make absolute value here, right? Yes. Absolute value is like the number. I make so complicated thing. Okay, so the difference is equal to goal minus sums, and lms, and we should check difference lms or limit. We should check it by the limit, right? If the difference can be if the difference remainder is 0, then we just should return lms. Else we should return lms plus 1. Lms plus 1, right? Yes, difference by limit. And same thing here. I think this should be correct. Let's see. So the difference again, let's just copy. What is the difference here? We make absolute value. Actually, it didn't even matter. If difference by the limit 0, then return lms. It seems that there can be a problem. Here 1 minus 1 1, answer 2, and let's check this test case. Let's test it. We should also make limit 100 and 0. Your answer is 1. Actually it should be correct, right? I think it doesn't matter less or more, so we just check for two things, right? We should check if the sum of the nums is equal to goal, then we return 0. If sum of the nums is more than goal, then we should check the difference, what is needed, fill with the limit integer number, and if the difference by the limit, if it's not divisible, there is some reminders, then we will plus 1. If less, and same thing. I fear, but that's my life. Let's do it. I never give up. Yes, sure, perfect, you know, perfect. Second problem done, and we have 4 minutes and 41. So we solved it in less than 15 minutes. Wow, 15 minutes was enough for me. Let's continue, please. Now the problem number 3. Oh my gosh, let's do it. I'm so excited. Okay, number of restricted paths from first to last node. Linked list. Okay, let me think about it. There is undirected. Oh my god. When you hear undirected weighted connected graph, is interesting. There is an undirected. Directed graph is that everything connects, right? As I remember. Yeah, undirected. I need to repeat this kind of stuff. There is an undirected weighted without directions. Yes, weighted connected graph. Okay, so the thing is that we have some graph, and each graph has some weight. Okay, you are given a positive integer n. We have some graph, and we have some positive integer n. Okay, which denotes that the graph has n nodes. Okay, labeled from 1 to n. Labeled from 1 to n. N nodes. Number of nodes. Okay. And nodes 1 to n. Okay, and then array edges. Okay, array edges. Where each edge is equal to some ui or vi and weight I. Oh my gosh. Okay, denotes that there is an edge between nodes u I v I with weight equal to weight I. This weight. Okay. A pass from node start to node end. Pass from node start to node end is a sequence of nodes. Is a sequence of nodes z1 to zk. A pass from start to end is a sequence of nodes z0 blah 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 zk. Oh my gosh. Such that z0 start zk end. A pass, one pass. Okay, I have lunchtime here, but let's do it. Okay, the key is end. Okay, and there is an edge between zi and zi plus 1 where I is less than k minus 1. Let's say I k minus 1, then so it is so complicated. If I is maximum k minus 1, then it means that here from 0 and z is like maximum k is like I, right here. Okay, from the 0 to the k. The distance of a pass is the sum of the weights on the edges of the pass. The distance of a pass is the sum of the weights on edges of the pass. Okay, let distance to last node. Distance to last node. Distance to last node x. Distance to last node x denotes the shortest distance of a pass between node n and node x. Node n and node x. So initially we go from the end node n and node x. Distance denotes the shortest between node n and x. Okay, restricted pass is a pass that also satisfies that distance to last node zi. Restricted pass. Now we talk about restricted pass. Oh my gosh, restricted pass. Okay, we should solve it. We have to solve it. Let's do it. The restricted pass is a pass that also satisfies that distance to last node. Distance to the weights of the from n to zi. Distance zi more than distance zi plus 1. Where blah blah blah. So I pass from start node to end. Okay, return the number of restricted paths from node 1 to n. Oh my gosh, 1 to n, number of restricted nodes. Since that number may be too large, return it modulo, oh my gosh, 10 to power 9 plus 7 modulo. A restricted path is a path that also satisfies the distance to last node. So this one, the zi, is what? Distance zi, as we know here, denotes where is our zi distance? Here. A distance of the path it denotes the shortest distance of a path between node n and x. So it means from zi, from zi, let's say 5 for example, from 5 to n, distance is so if this yes, so if the sum of the weights, right, here we denote the path, right here, a path is a sequence of nodes such that blah blah blah. The distance of a path is here, the distance, they define the distance of a path is the sum of the weights. Okay. So if the total weight of something is more than the next one, then it is restricted path. Okay. And return the number of restricted paths from 1 to n. Okay, okay. Whew. Example. Yeah, this is crazy problem. Yes, okay. Let's do it. Input number n. We have a 5 nodes. H 1 2 3 1 3 3 2 3 1 blah blah blah. As you know, let's see, H, it is between H between u y and vi with weight equal to weight I. So it means that between 1 and 2 there is 3, right? Between 1 and 2 there is 3. Let's see the H. H is a list of lists, and each list here is a node, right? So no, it is a weight. So 1 2 3. 1 2 3. Okay, so let's say 1 2 is weight 3, 1 3 is weight 3, 2 3 is weight 1, 1 4 is weight 2, and so on. Okay, output 3. What is this? Okay, we should like move to all the directions. I don't know. Each circle contains the node number. Each circle contains the node number in black and its distance to last node value in blue. Its distance to last node. Last node is what? 5? We have fixed numbers, right? From 1 to n. Okay, so from 1 to 5, right? From 1 to 5. From 1 to 5, it says 4. Why? Here, the minimum. Talk about this minimum distance, right? Is there any word called minimum? No. Then why is that? 1 3 5. Okay. 1 2 5. Each circle contains a number in black. The 3 restricted paths are 1 2 5. 1 2 5. Why it is restricted? Because no, I didn't understand. 1 to 5, it is restricted. This is H, and this is distance node. We should think about distance node. So distance node 4 to 0. Yeah, the last one, of course, 0. This one 1. Okay, 1 2 3 5. 1 2 3 5. And restricted path satisfies distance less than zi plus 1, zi plus 1, and denotes the shortest distance of a path. Well, here what they are using, distance is shortest distance of a path. What does it mean, shortest? Actually, I think that I would ask the interviewer about this question, like, what does it mean in shortest distance? The distance is the sum. So here, the distance is the sum. Shortest distance means minimum sum, right? Yes. So 1 2 3 5. Why it is restricted? 1 to 5. 1 to 5 is restricted because it is more because 1 is more than It's difficult to understand because question actually. 135. 135. It is always from 1 to n. I didn't read it carefully. Returns the number of restricted paths from 1 to n. 1 to n. From the first to the last. Okay? How many restricted? So, how many restricted paths? And each path. How many restricted paths? How many? Returns the number of restricted paths. Okay, so let's see. Return number of restricted paths. Restricted paths. Okay. Meaning of restricted paths is what? Is path that satisfies distance to last node. Distance to last node. Zi is more than distance to last node Zi plus 1. Zi plus 1. Okay. And next one. What is distance to last node x? Distance to last node x is shortest distance between n and x. Shortest distance between n and x. And now we come to the definition of distance in general. Distance. Yeah, they know how to make the task difficult to understand. Sum of the weights sum of the weights sum of the weights on the edges of path. So for example, here 4 is the minimum 3 1, for 4 is 2, for 3 is 1, for 4 minimum is 2 3 1. Now I got it. Okay. Seems better. Okay, and so we have now distance is the sum of the weights on the edges of a path. Weight and edges. Edges of the path and edges, and we have also edges. Edge I is the list of ui, any actually we I and weight I. And weight oh my gosh, let me think about it. So what we should do, we should return the number of restricted paths. Restricted path is a distance to last node some Zi is bigger than Zi plus 1, and Zi is generally a path from start to end sequence of nodes 0 0 zk. Ah. So, for example, when distance to last node 1 is more than distance to last node 2, then it is restricted path. And distance to last node, generally, x is the shortest distance between n and x. So in this case, when the shortest and distance sum of the weights, so when the sum of the minimum sum of the weights, when the minimum sum of the weights for some zi is bigger than the next one, then it is a problem and it is called restricted path, and we need to check it. And how do we need to return the number? We need to return the number. Oh my god, number. So every time when we will have this path, it is restricted. Question: should we go through the all paths and check every time the distance? Okay, what are we given? We given n and h and list. Why did they say here about model? The number will be too large. Number of restricted paths can be. Oh my god, well, seriously? Oh my gosh, 1 to 5. Let me understand. Second example. Second example, let's see. Okay, this was everything connected. How about this one? N is equal to 7. But why? 3, 7. Each circle contains the node number in black and its distance in value. Okay. Node number in black. The only restricted path is 1, 3, 7. Time is up, guys. A restricted path is a path that also satisfies that distance to last node where I is somewhere between 0 and k minus 1. What does it really mean? 1, 3, 7. So we have here minimum 5, here 4, and 1, 3, 7 is restricted. How about others? How about the path like, I don't know, 2, 5, 7? And here 1, 3, 4, 1, 7, 3, blah blah blah. Oh my gosh, I think it's there is at most one edge between any two nodes. There is at least one path between any two nodes. Oh my gosh. Difficult. This is a medium problem. I think. Oh god. This is even worse. Okay, let me try. Anyway, that one is not so easy. You are given an array nums and an integer. Okay, let's make it 20 minutes again. Make XOR of all segments equal to 0. XOR of all segments equal to 0. Okay, you are given an array nums. You are given an array nums. Yes. An integer k. Okay. The XOR of segment left right. Segment left right. The XOR of segment left right. the XOR of segment left right, where left is less than or equal to right, left then is equal, left is less than or equal to right, is the XOR of all the elements with indexes that indices between left and right. XOR, okay. Inclusive nums left, XOR nums left plus 1, XOR blah blah blah. It returns the number of elements to change in the arrays such that the XOR of all elements of size k is equal to 0. What? I didn't understand the question at all, but I will solve this fucking hard problem. Return the minimum number of elements to change. Okay, we need to return the minimum number of elements to change. So that is the XOR of all segments. XOR of all segments of size k size k is equal to 0. What is fucking XOR? How do you get the logical XOR of two variables in Python? For example, I have two variables that I expect to be strings. I want to test that only one of them contains a true value. The operator, this one, seems to be bitwise and not defined on all objects. Okay. If you are already normalizing the inputs to booleans, then not equal to is XOR. What? You can always use definition of XOR to compute it from other logical operations, A and not B, or not A and B. But this is a little bit terrible for me. It's just maybe like this, XOR from operator import XOR. True. What the hell is this XOR? Can anybody explain me? Bitwise XOR operator. Python bitwise XOR operator returns 1 if one of the bits is 0 and the other bit is 1. 1 if one of them 0 or 1. If both bits are 0 or 1, then returns 0. So 1 if different, 0 if same. Okay. Any more? Converts inputs to booleans. Use the bitwise XOR operator or XOR. Oh my god, well. I do not understand. XOR operator. A is equal to 10, 1 0 1 0 4. A and B, bitwise AND operator. Oh my gosh, what is XOR? Shame. I think I don't even know properly the bitwise. Okay, bitwise XOR operator. Oh my god, 1 minute. 6 bitwise operator. Bitwise operator. Okay, we talk about bitwise operators. Bitwise operator. So and 10 and 7 is equal to 2. What? Simple example. Or 15 power. Isn't it power? XOR. Ah no. Power is 2 times star. XOR operator. Python bitwise XOR operator returns 1 if one of the bits is 0 and the other is 1 if both bits are 0 or 10, 7, 13. What the hell is this? 8, 10, 7. So here 0 and 1 returns 1. 1, 1, 0. 1, 0, 1. 1, 0, 1. And it is 1, 1, 0, 1. It is what? 2 to the power 0, 1, 2, 3. 2 to the power 3 plus 2 power 2 and plus 2 power 0. It is what? 2 power 8 plus 4 plus 1. So it is 9, 13. Oh my godable. Oh my godable. Yeah, this is bitwise operator is 2 to the power of number 0 or something. Interesting. Let's see the example. Nums 1, 2, 0, 3, 0. K is equal to 1. Segments of size 1. Output 3. Modify the array from 1, 2, and 3 to form maybe, right? To form, I think this is mistake. 0, 0. Let me reread this task. You are given array nums and integer k. Okay, integers and k. The XOR of a segment left right, where left is less than the right. Is the XOR of all the elements with indexes between left and right. Inclusive nums left, nums right. XOR. Naming number of elements chain is array such that the XOR of all element segments of size k. What does it mean size k? Yeah, is equal to 0. Let's see the size k. Modify the array from 5 to 1. 7, 3, 4. Ah, so it means what? 347 XOR is equal to 0. Let me check something. So how do we make it in Python? XOR for of array, XOR of array in Python. Oh my god. Previously there was some get file here. No. No. Ah, sorry. Here. XOR boolean A boolean B. Just XOR, maybe like this. XOR. Let me check something. Print XOR. No, let's make it number 1. Let's import from operator. Import XOR of the list 347. Yes, map XOR Python Stack Overflow. XOR of 1 2 3. So for the several XORs, XOR for 3 numbers, Python. Well, but okay. What is this? One time, wow. Come on. We have 20 minutes, we can do it. Oh my gosh, 20 minutes for this problem. I think I can solve it. Yes. We need a consecutive only, right? Yes. So we need to find the XOR, how many elements to change. Number of unique triplets whose XOR is 0. Difficult and four XOR 7 XOR. Yes, I can make it like this. XOR something something. Huh? Let's say A is equal to 7 3 4. 7 3 4. Okay, so for I in and this is, let's say, XOR num, let's say 0. For I in for I in A, XOR num is equal to, let's say, is equal to I, print XOR num. That's why I didn't solve previously this kind of problems. Print. Thank you. Yours and out 0. Wow, really? Oh my gosh. So we have K and we have this one. So Mhm. Okay. Did they copy? Oh my gosh. March 7. Right now. Wow, really? He made it just right now? How is it possible? So here for this problem, I know how to count the XOR, right? But I don't know how to make it 0. Like, how does it make these numbers? 7, 3, 4. No idea. It's here they had 3, 3, 4. Every 3 numbers XOR 0. I think it's not really that difficult problem, right? How much time do I have? 10 minutes. Let's do it. 12 minutes. Yes, so the point is, that's it. Nums 2.10. Okay. Numless 2000. K is some number, right? We have K. So what we need to do is we should check for some number of K. So we have some list of numbers and we have some K. There we go. K. Okay, we go with this K. Okay, and the thing is that how do we know how many minimum number of elements to change. How do you know how many numbers we need to change out of the list to make the XOR? How do we know how many numbers to change to make XOR 0? Top 10 XOR problems. How about Leetcode itself? I think this is my weak point, right? And not many problems for XOR, even in Leetcode. Out of 1.5 thousand, only like 10 problems. Really? And never solved any problem for XOR. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 problems for XOR. And no problem solved here. Really? Okay. Oh my gosh, my brain is not that smart for solving these problems. I think here we could probably change the numbers 2, 5 and 4, 5, and after it we could try to make all possible arrays and What? Oh my gosh, these problems are really difficult and hard. I need to learn to solve hard problems. Oh my gosh, this is just wasting of my time. Yes, I need to solve the XOR problems, and that logic problem for node is really difficult for me. Okay, thank you guys for today. Let's see the results, and let's see how our contest is going right now. I think if we update this web page, we will see the ranking. Oh, this guy solved 18 minutes. Thank you. How did he solve it in 18 minutes? Oh my god. In Java, 1000 problems guy is done. Oh my gosh, really? 1000 problems. Can you think about it? He solves every, right? 3000. Oh my gosh. So he solved all of these problems like easy level for him. Oh, mistake. Haha. Even the best person in the world made the mistake. That's it. So he solved even faster. He's here. So he solved the first problem within 1 minute and 30 seconds. Oh my gosh, even I spent 7 minutes just to understand the problem. He solved it because this guy is really the brain. Google brain. And here the second problem. Wow, by the way, I am 3130. Good results, you know. Score 7, but it's better, it's faster. Okay, 3000. World rank 12,000. 26 minutes. I think it's not bad, but I could make more results with XOR and this and that. I think it's very interesting. Wow, I cannot see their solutions right now. Yes, right. I can see only the solutions when they are already done, right? For the other contests. So contest, let's see. For example, yes, here is this. Here's there. This guy is really awesome. Who is this boy? Okay. Okay. Thank you so much, guys. See you next time.